Imagine a world where your imagination no longer lives only inside your mind. You sit alone in a quiet room, thoughts drifting like clouds, your head filled with colors, shapes, and scenes no one else has ever seen. And then, through a seamless blend of neuroscience and artificial intelligence, those fleeting inner visions begin to take form in front of you. Lines appear, colors spread, textures emerge. Within minutes, your thoughts transform into a painting, tangible, vivid, and real. This is the story of the machine that turned thoughts into paintings, a breakthrough that reshaped creativity and redefined the boundary between mind and matter. At first, the concept sounded like science fiction. How could a machine possibly understand imagination? Thoughts are invisible, fluid, emotional. They shift and dissolve before we can fully grasp them. But researchers believe that behind every image in the mind lay a physical process. Neurons fire in patterns. Electrical impulses move across neural pathways. Every memory, every fantasy, every dream leaves a trace. A complex signature written in the language of the brain. If those patterns could be decoded, perhaps they could be translated. The early experiments were awkward and imperfect. Volunteers sat in laboratories with electrodes attached to their heads, concentrating intensely on mental images while a computer attempted to interpret their brain activity. The first results were chaotic. Blurry shapes, distorted forms, splashes of color that barely resembled the intended image. Critics dismissed the project as ambitious but unrealistic. Yet the scientists saw something promising in the noise. The machine wasn't guessing randomly, it was responding, it was listening. Over time, the algorithms evolved. The artificial intelligence was trained not only to detect patterns of electrical activity, but also to associate those patterns with emotional states. Joy carried a different rhythm than sorrow. Nostalgia differed from fear. These emotional signatures influenced color palettes, textures, and composition. The machine began to understand that imagination is not just visual, it is emotional. The breakthrough came during an ordinary test. A volunteer closed his eyes and recalled a childhood memory, a meadow near a river, sunlight filtering through leaves. He offered no verbal description. He simply focused on the memory and allowed it to surface fully. The system processed his neural signals, mapping the firing neurons and translating them into visual data. When the painting appeared on the screen, the room fell silent. It was rough, not photographically accurate, but unmistakable. A river shimmered in soft blues. Grass glowed in layered greens. Sunlight fractured through branches in warm streaks of gold. The machine had not copied a picture. It had interpreted a memory. News spread quickly. Artists, technologists, psychologists, and dreamers gathered to witness what many called a new era of expression. For painters, the machine became a collaborator. Instead of struggling to transfer a precise feeling onto canvas, they could project their mental image directly into visual form, refining it afterward with their own touch. Poets watched abstract metaphors transform into landscapes. Musicians imagined melodies and saw them bloom into cascading waves of color and motion. Creativity was no longer limited by technical skill. The gap between vision and execution had narrowed dramatically. But with wonder came concern. If a machine could read thoughts well enough to transform them into art, what protected the privacy of the mind? Could such technology be misused? Could unspoken fears or secrets be extracted without consent? The developers recognized these risks and implemented strict safeguards. Neural data required active participation. Encryption protected every session. Still, society wrestled with the implications. For the first time, imagination was no longer entirely private. As the technology matured, the hardware became less intrusive. Bulky electrodes gave way to lightweight neural headsets capable of capturing signals with remarkable precision. Calibration times shortened. The AI adapted to individual users, learning their mental patterns and stylistic tendencies. It even began to anticipate creative intent, suggesting subtle variations, a deeper shade of blue, a shift in perspective, a new interplay of light and shadow. Artists described the experience as watching their subconscious come alive, revealing layers of imagination they hadn't consciously explored. The creative possibilities expanded rapidly. Dreams could be reconstructed and examined visually. Surreal concepts that defied language, floating cities, impossible geometries, hybrid creatures, could now be shared instantly. Children who struggled to express themselves verbally discovered new ways to communicate their inner worlds. Psychologists use the technology therapeutically, helping patients visualize complex emotions and memories that were difficult to articulate. Historians and educators used collective imagination to reconstruct speculative scenes from the past, blending research with creative interpretation. Yet the paintings always carried a dual signature. They were born from human thought, but shaped by artificial interpretation. Each image was a dialogue, a collaboration between organic imagination and computational insight. This raised profound questions about authorship. When art emerges directly from neural activity, who is the creator? The human who imagined it? The AI that translated it? Or is it a shared creation, inseparable in origin? Despite its power, the machine revealed its limitations. Not every thought could be captured. Some ideas flickered too briefly. Some emotions resisted structure. The mind is fluid, layered, and often contradictory. The AI could interpret patterns, but it could not force inspiration. Creativity remained an unpredictable force. The most compelling work still required intention, focus, and vulnerability from the human participant. The machine amplified imagination, but it could not replace it. Perhaps the greatest impact of the technology was philosophical. For the first time, thoughts could be preserved in their raw, pre-verbal state. An idea that might have vanished in seconds could now endure as a physical artifact. This shifted how people understood the mind itself. Imagination was no longer an invisible, solitary process. It became something shareable, examinable, and enduring, a bridge between the fleeting and the permanent. And yet, a quiet mystery remained. Even with advanced algorithms and precise neural mapping, there were always aspects of imagination that slipped beyond capture. Fleeting intuitions, wordless sensations, half-formed dreams. The machine illuminated much, but not all. In that gap, creativity retained its magic. As this technology reshaped art and expression, one truth stood firm. The spark of imagination still began within the human mind. The machine could interpret, enhance, and visualize, but it could not originate the initial thought. It could not dream on its own. It relied on the quiet, chaotic brilliance of human consciousness. The machine that turned thoughts into paintings did not replace artists. It empowered them. It dissolved barriers between vision and reality. It invited collaboration between neurons and networks, emotion and algorithm. In galleries of the future, walls would display not only paintings, but the essence of thought itself, moments of imagination made visible. This innovation was not an ending, but an opening, a doorway into unexplored creative territory. Each painting became proof that imagination, once intangible, could be seen and shared. And as humanity stepped into this new era, one thing became clear. When technology listens carefully to the mind, it does not silence creativity. It gives it a new voice, a new canvas, and a new way to be alive.